Hi, I'm Randall Barney, WTA's Membership Director. We're at IBC speaking with industry executives about the impact and evolution of new technologies in the teleport services and technology segment.
Well, technically, it's here. We've got the consensus, we've got the specifications, we've got the standards. So modem manufacturers are going ahead. So we probably have about 80% of the modulator market covered now. And I think the DSNG encoder market, we're probably 50% there and growing. But it's certainly on the map. And with the FCC demanding carrier ID or a form of carrier ID by June 1st next year, this is helping push, at least on the American side, getting carrier ID real. It's a struggle. Messages have got to go out. We've got to get there. We're finding integrators perhaps don't understand the situation fully at the moment, and that's something we're targeting here at IBC this year. So it's great, we're getting there, but it's, as always, any global initiative, we just need everybody's help, everybody from WTA and all of the above. Good old VSAT. Well, VSAT is its own worst enemy in a way because it's so successful, thank goodness. It's big, it's massive. And you're talking 100,000 plus terminal networks, talking even 1 million terminal networks now. I think that's just happened, that's been published. And it's going to grow, and it should grow. The problem is the technology there to keep it in line, to stop it being interfering or causing adjacent satellite interference is the big one. The small terminal, badly installed. We've heard all this before. It gets us rather depressed, which is a bit sad because it is a great industry and it's going to move. When the advent of HTS and everything else now, VSAT's here, but we've got to get it better. So there's two thoughts. Better tools to find the problem, but equally, our colleagues in the VSAT industry are making better terminals, better closed-loop systems to deal with managing these, vast networks. So they're the two keys. The good news is, for our side, is we've got a new product called SatGuard from a company called VSAT, but that was developed through member input. That product, just one example on a North American VSAT system, only 2 months ago. For 2 years, a satellite operator struggled in finding what was wrong. The new product went on, 10 minutes later, 5 terminals found, 5 terminals switched off, job done, system perfectly working. For once, this is great news. We can now find the problem from being the remote side of the problem. And it hasn't affected the network operators, it actually helps them. And we're finding our colleagues, the Hughes and the VSATs and everybody else are starting really, this is good news. This is cheering us all up. That one product has just made our lives totally different. It's fantastic. So watch this space, learn about it. If you're a satellite operator, all I can say is get one now. You'll love it. This is the way it's got to be. We can fix it. But I think the key is we could do better with the system design. And so I'm hoping that with the pluses of SatGuard, we can now start to really get together as engineers and start figuring out what else can we do. Use a bit of buzz. It's good for us. Yes, I think everybody should always look carefully at the designs. I think everybody should take care and think quality. We sometimes look for the cheapest option. I'm not sure that's always the best option. Equally, we need to look at the programs available. Now, I know the WTA are about to announce the certification program for uplink. This is just fantastic. We were just talking about this the other day. This is where other initiatives can be glued into that program. Likewise, GVF with their training and installation certification program. This is all good stuff. It helps us where, if you like, IRG is truly the engineering of the satellite operator. That's what we if you like, represent. So our task is to keep building more tools, and we need every idea in the book. We're open to, the craziest ideas can sometimes become the best. SAT going back to VSAT, that came from a really wacky idea from one engineer. We now have a solution. So maybe we should all be brave. Get those ideas on the table. Some of them won't fly, just ask me, I'm good at that. But some will, and that makes a difference. Just the working together. Big data. Well, it's interesting. We produce a lot of metrics. Our colleagues in the satellite operators have been producing metrics for some years. This has helped a lot to figure out what's the real problem. And VSAT's come out as a target, along with where carrier ID came from. But there's still individual metrics. There's still those statistics that we try to join together, but we're being quite amateurish. Do we really know what the global impact of interference is? Yeah, I think the engineers do know it, but we don't actually know what the answer is. So my thinking is, if we've got lots of data, lots of information, we should start bringing it all together, all of us. And eventually we could have one place to put that. We then get that data to work. And then we've been looking at the Watson machine from IBM and using deep learning algorithms. This is, if you do this, you can start to find solutions that you never found before. And then we could even measure how successful we are, whether carrier ID was effective, how much did it fix, how much did SATGuard fix, what's the effect on the industry about training. At the moment, we know it, but we don't know it. So yeah, it's a small amount of big data, very specialized, but big data it is, and we should use today and tomorrow's technology to help us and help new operators, new people get that information faster, quicker, and accurate. If we're accurate, we will nail it. That's it. Simple. Well, to be honest, I think it's getting better. I think that the future for us is we stay in our engineering. That's what we do best, and that's where we've tried to keep contained in, because we've got great groups doing many other things. It's making sure we don't trip over ourselves. I think it sounds rather boring, but that's something it's important. But the real future is the fact that I think we are curing and fixing interference. I think the future is using that data we talked about, bringing and welding all these things together to become one united tool, if you like, for the world. We could perhaps use the Space Data Association, something like that. We need to get that glued together. That's going to take a little while. That's a bigger, that's a big piece of a puzzle. But that's what I think the future is. But also, I think we have to make sure that interference, it will grow because the services are growing exponentially. HTS, everything else, it's growing big time. We've got to keep the lid on interference and keep it linear so that it's a reducing problem compared to service capacity. That's the tough one. We need to measure it and keep it linear. If we let it go exponential, we're in trouble. So there's my thing. We need to glue all this great thinking together, and we need to keep an eye on the metric of, are we keeping linear interference? Is it creeping downwards, or are we letting go? We need to know that.